In this tutorial, we're going to look at the reaction time analysis. And I will start where I stopped tutorial 2. I have 3 subjects with data exported from ProLab, and I've read the data and interpolated gaps in that one. And if you don't have a lot of stimuli, you could actually just run tutorial 3, which is the one with the looking times. And when you get to the point where you extract the results, you could just change the measure, which we set to AOI looking time, to latency. And you will get the latency to the AOI in that tutorial. However, that's not very practical if you have lots of different stimuli. And many times when you have reaction times, you have something like this. This is the data that we have in the ProLab experiment. You can see that there are lots of different stimuli, and they move. Position of the objects move between each stimuli, and the target has different positions. And actually, if we search for as target 1, that means that there is a letter T among all the L, we can see that there are 50 trials. So this is not very uncommon. But if you do it with the strategy we used for looking times, you would have to add 50 AOI definitions. And that takes a very long time, and it's not very efficient, and Time Studio can do better than that. And I'm going to show you how. So the next step, after reading the data, you have to select which data to use. And we use event modification. If we scan the event names, we can see that here are all the events. And we're interested in just a few of these. The ones that have a name that ends with has target 1. And this takes a bit of time, but the good thing is that when you have lots of stimuli that you created, you usually know the position for the AOI in all the stimuli. And I prepared what that could look like in an Excel sheet. So here are all the events with has target 1. And it's not offset at all, so the event will come at the start of the stimuli. And we'll rename all of these to RT, like reaction time. But I also added a column for the X position and the Y position of the AOI, and also the name of the stimuli, so we can later use that when we define the AOIs. So I'm going to copy this and paste it into events modification, like that. And we're gonna run that. The next step is to reject artifacts and bad events or bad eye tracking. And we are looking at the reaction time from the start of the image, and 3 seconds is good. We can plot the X and Y position, and we can just set an automatic reaction. If we have less than 90% data, we'll just skip that trial because it won't look very good. And of course, as usual, you can look at the data to see if it looks okay or not. But I'm just going to run this. We can see that it directed 2 trials for subject 1 and 1 trial for subject 3. Great. So it's now time to define the areas of interest. We start with using eye-checking AOI clear in case we need to run the AOI definition multiple times. It's good to be able to clear what's in that data structure as well. And now comes the tricky part. We use eye tracking AOI define like this. Now we're going to look at the eye tracking reaction time event from 0 to 3 seconds. We can set the resolution of the screen like that, and the stimuli to any stimuli in your the folder where you kept your images in this case. So I'm just going to take one of them like that. And then we're going to have 2 AOIs. One will be at the center. And we can make it a bit bigger, like that. And we're going to have a target. And in this image, the target is here. But for another trial, it will be somewhere else. So how can we change that? Well, if we go to, if you right-click on this preview window, we can go to the first event. It says current event is number 1, reaction time, and you get the name of the stimuli and the start of the event and so on. Then we can use the F5 and F6 keys to jump between trials. You can now see that in trial 2, the T should be over here. But the target is still here because we've set a fixed position here. So do you remember that I had 2 columns for the AOI position? That was called posX and posY. So if we enter that here, you can see that the AOI moved. And if I go back to the first event, it automatically uses the coordinates that you provided in event modification. So that is a good way to handle large amounts of trials. And there's just one thing to be a bit cautious about. If you change something, for example, change the size, just pressed enter, it will update this to the static position. So if you see numbers here or something else that doesn't say position X and position Y, you have to reset that. And then we are done with this AOI definition. Oops. See, it changed. So let's change that and use the plugin. And once we've done that, Time Studio sorted out the positions and so on, so that we got the right data. And we can use the AOI results to get the reaction time to the target. Well, let's plot the mean of the trials. Latency, that is correct already. And we can also have a condition that the gaze has to be in the center, or at least 100 milliseconds. It's quite nice to also You can plot the individuals and use the long format, which I prefer because it's easier to use for statistical analysis later. You can save this as tutorial reaction time. And when I run this, I get the mean reaction time for the target. We got the overview of for the whole group. We also have all the data that we can copy into a spreadsheet. So we can see which subject has done what for which trial and so on. So if you remember, there were 9 trials. We rejected 2 from subject 1, so that's why we have 7 trials here. We didn't reject any trials from subject 2, so it's 9, and here it's 8. And you also get some extra data that might not be interesting to add to the analysis, but the percent data might be good to look at in case you have. If you haven't rejected any events previously, you can use this to filter out some data with really low amount of data. And this is the value which we set to the latency. So this is the actual latency. And for some trials, there are no reaction time because the gaze didn't go to the target or the gaze didn't stay long enough in the center. And then we also had the individual plots so that you can check for outliers. So for example, this one, 2.4, looks a bit high. Maybe that's not a relevant value, or 2.2. And that was that. See you.